watching Big Brain Energy. There are some things which you never buy together, like petrol and diesel, and there are some things which you often buy together, like shampoo and conditioner. We call these substitutes and complements. How exactly we classify these items is what we're diving into today, using cross-price elasticity. This is the third video in our Elasticity of Demand series. If you haven't already, check out our other videos in this series. We cover everything you need to know for the elasticity topic within NCEA 3.3 Demonstrate Understandings of Microeconomic Concepts. Let's crack into it. Cross-price elasticity of demand, or XED for short, measures the responsiveness of quantity demanded of one good to a change in price of another good. This is a definition you'll need to memorize for the test. Basically, it says if the price of something increases, how does this affect how much people will buy of something else? Like, if the price of Coke increased, people would want to buy more Pepsi. Exactly how much more would they want, and why? We classify pairs of items as either substitutes or complements. Substitutes are goods that are typically used instead of each other. For example, Coke and Pepsi, or butter and margarine, or Macca's and BK, canola oil and sunflower oil, or Spotify and Apple Music. For each of these pairs, you usually just buy one or the other, and not both. You probably don't have both Spotify and Apple Music, right? They serve the same purpose, so you just need one. They're substitutes. Though I'm willing to die on the hill that Apple Music is superior. Complements are goods that are typically brought together. For example, movie tickets and popcorn, or bread and butter, left shoes and right shoes, or concert tickets and merch, or burgers and fries. When you buy one of these things, you'll often buy the other two. If you get a burger from Macca's, you'll probably buy some fries too, right? They're complements. To determine whether something is a substitute or a complement, we can use an equation. Depending on what the answer to that equation is, tells us how exactly to classify it. If the cross-price elasticity is positive, then the goods are substitutes. If the cross-price elasticity is negative, then the goods are complements. This exists on a spectrum, meaning things aren't strictly one or the other. Certain things can be more strongly one way or the other. Something like left shoes and right shoes, for example, are probably stronger complements than bread and butter, unless for some reason you have one leg. To calculate cross-price elasticity, there are two main methods. You'll notice that they're quite similar to calculating price elasticity. The first method is the percentage change method. The formula is cross-price elasticity equals the percentage change in the quantity of one of the goods over the percentage change in the price of the other good. So we're looking at the change in quantity of one thing in terms of the change in price of another thing. Let's do an example. Suppose, when the price of a movie ticket rises by 12%, the quantity demanded for popcorn decreases by 10%. Calculate the cross-elasticity of demand between movie tickets and popcorn and determine if they are a substitute or complementary goods. The percentage change in quantity of popcorn is negative 10. It's decreasing by 10%. The percentage change in price of movie tickets is positive 12. It's increasing by 12%. Negative 10 over 12 equals negative 0.83. Let's take a look again at our rules. If XED is positive, then the goods are substitutes, or if XED is negative, then the goods are complements. In this case, XED is negative, so popcorn and movie tickets are complementary goods, which makes sense because movie tickets and popcorn is something that you would typically buy at the same time. The other method of calculating cross-price elasticity is called the midpoint method. Fair warning, the formula looks pretty scary. Cross-price elasticity equals the new quantity of one of the goods, QA2, minus the old quantity of that good, QA1. So like if the amount of popcorn sold decreased from 100 to 70, it would be 70 minus 100, over the old quantity plus the new quantity divided by 2. This bottom half of the fraction is just calculating the average quantity. And then we get a little scary here. We take all of this and we put it over the same thing for price. So the new price of the other item, PB2, minus the original price of that item, PB1. So the new price of the other item, PB2, minus the original price of that item, PB1, over the average price. So the original price plus the new price over 2. In this formula, Q stands for quantity, P stands for price, A stands for one of the items, so everything with an A refers to the same item, and B stands for the other item you're looking at. 1 stands for the old version, and 2 stands for the new version. The brackets mean that you simplify those mini fractions first. Okay, crikey, let's do an example. Suppose that when the price of movie tickets rises from $20 to $25, the quantity demanded for popcorn decreases from 100 buckets to 70 buckets. Calculate the cross-elasticity of demand between movie tickets and popcorn and determine if they are substitute or complementary goods. The cross-price elasticity equals the new quantity of popcorn minus the old quantity, so 70 minus 100, over the old quantity plus the new quantity, 100 plus 70, over 2. All of this over the new price of movie tickets minus the old price, so 25 minus 20, over the old price plus the new price, so 20 plus 25, over 2. And that's it. Whew. Let's solve this now. The top half of the fraction works out to be negative 0.35, and the bottom half of the fraction is 0.22. Negative 0.35 over 0.22 equals negative 1.59. And there's our answer. The cross-price elasticity between movie tickets and popcorn is negative 1.59. Let's interpret this. Our rule said that if XED is positive, then the goods are substitutes, or if XED is negative, then the goods are complements. In this case, it's negative, so popcorn and movie tickets are complements, which makes sense because you often buy them at the same time. So that's the two methods of calculating cross-price elasticity. The last thing you need to know for this topic is about how to illustrate these effects on a graph. There are only two scenarios you'll be asked about. Firstly, that the items are complements, for example, movie tickets and popcorn, and the price of one of them increases, say the price of movie tickets increases. When the price of movie tickets increases, the demand for popcorn decreases. Basically, if movies become more expensive, you wouldn't go there as much, so you don't need as much popcorn. We show this on a graph by first drawing a graph for movie tickets, then a graph for popcorn. We use a typical market graph which has price on the y-axis and quantity on the x-axis, and a downward sloping demand curve. It doesn't matter if you draw this demand curve straight like this one, or as a curve. Then you show the price of movie tickets increasing, from P1 and Q1 to P2 and Q2. Next, we'll draw the graph for popcorn, showing the demand for popcorn decreasing. This means that we draw a new demand curve, D2, to the left of the original demand curve. So you can see that the price for movie tickets is increasing, and the demand for popcorn is decreasing. This is the first scenario you may have to draw. The other scenario is when there is a price increase for a substitute good. When the price of, for example, Spotify increases, the demand for Apple Music increases. Basically, if Spotify got more expensive, a lot of people would just turn to the dark side and get Apple Music. So, just like before, we draw a graph showing the price of Spotify increasing. This graph looks exactly the same as the one we drew for movie tickets, with P1 and Q1 moving to P2 and Q2. Then, we draw a graph to show the demand for Apple Music increasing by drawing a new demand curve, D2, to the right of the original demand curve. Alright, so that's all the graphs you'll need to know. The price of one thing increases, and that either decreases or increases demand for the other thing, depending on if it's a complement or a substitute. Alright, so I know that's a lot of new information, but that's everything you need to know for this topic. Here's a full summary. Substitutes are goods that are used instead of each other. Complements are goods that are brought together. If XED is positive, then the goods are substitutes. If XED is negative, then the goods are complements. There are two main ways of calculating cross-price elasticity, the percentage change method and the midpoint method. We can illustrate the effect of a price increase on some graphs. The top two graphs shows the situation for complements, and the bottom two graphs shows the situation for substitutes. So then, let's try and help this new material stick in your lovely brain with some practice questions. Feel free to pause the video to answer the questions if you need more time. Firstly, what are substitutes? Substitutes are goods that are often used instead of each other. What are complements? Compliments are nice things you say to other people. Kidding. They're also things that are often brought together. Which of these pairs are substitutes? Coke and Pepsi, movie tickets and popcorn, or burgers and fries? The answer is Coke and Pepsi. You usually just buy one or the other. Which of these pairs of items are complements? Macca's and BK, bread and butter, or Spotify and Apple Music? The answer is bread and butter. Often you'll buy these things together. Which of these pairs are substitutes? Printers and ink, concert tickets and merch, or canola oil and sunflower oil? The answer is canola oil and sunflower oil. They do basically the same thing, so you usually just buy one or the other at once. Which of these pairs are complements? Red apples and green apples, PS5 and the Lego Batman game, or the Harry Potter book and the Harry Potter audiobook? The answer is the PS5 and Lego Batman. Often you'll buy a few games when you buy a new PlayStation. Here are some calculation questions now. When the price of smartphones rises by 10%, the quantity demanded for phone cases decreases by 6%. Calculate the cross elasticity of demand between smartphones and phone cases. The question has given us percentages, so we use the percentage change method formula. The percentage change in quantity of phone cases is -6, since it decreases by 6%. The percentage change in the price of smartphones is +10, since it increases by 10%. -6 over 10 equals -0.6. This is a negative, so smartphones and phone cases are complementary goods, which makes sense because often when you buy a new phone, you'll also buy a new charger. The next question says, when the price of public transportation decreases by 5%, the quantity demanded for gasoline decreases by 3%. Calculate the cross elasticity of demand between public transportation and gasoline. The percentage change in the quantity of gas is -3, since it decreases by 3%. The percentage change in the price of public transport is -5, since it decreases by 5%. -3 over -5 equals 0.6. So, because the answer is positive, public transport and gas are substitutes. Which makes sense, because if you take the bus, you don't need to buy petrol. You often don't buy both at the same time. The next question says, suppose we have two goods, raincoats and umbrellas. We want to calculate the cross elasticity of demand for raincoats with respect to the price of umbrellas. The price of umbrellas increases from $15 to $20 each. As a result, the quantity demanded of raincoats decreases from 120 to 100. Here we have numbers rather than percentages, so we need to use the midpoint method. The new quantity of raincoats is 120, minus the old quantity, 100, over the old quantity plus the new quantity, 120 plus 100, over 2. All of this over the new price of umbrellas minus the old price, so 20 minus 15, over 15 plus 20 over 2. Alright, let's calculate this. The top half simplifies to -0.18. The bottom half simplifies to 0.29. -0.18 over 0.29 equals -0.62. This is a negative number, so raincoats and umbrellas are complementary goods, which makes sense because often you'll use a raincoat and an umbrella, unless you're in Wellington, where an umbrella only lasts 2 seconds. Here's another question. Suppose we have two goods, sunglasses A and sunscreen B. We want to calculate the cross elasticity of demand for sunglasses with respect to the price of sunscreen. The price of sunscreen increases from $10 to $14 each. As a result, the quantity demanded of sunglasses decreases from 80 to 70. Again, we use the midpoint method. The new quantity of sunglasses is 70, minus the old quantity of sunglasses, 80, over 80 plus 70 over 2. All of this over the new price of sunscreen minus the old price of sunscreen, so 14 minus 10, over the average price, so 10 plus 14 over 2. The top half simplifies to -0.13. The bottom half simplifies to 0.33. -0.13 over 0.33 equals -0.39. This is a negative number, so sunglasses and sunscreen are complementary goods. Which makes sense, because on a hot day, you might want to pick up some new sunnies and some sunscreen to slip, slop, slap. The next question says, show the effect of an increase in the price of Cocoa Pops on the demand for milk. This means draw some graphs. Firstly, Cocoa Pops and milk are complements. So, when the price of Cocoa Pops increases, the demand for milk decreases. Because if Cocoa Pops are spinny, you'll use less milk. So we need a graph showing the price of Cocoa Pops increasing and a graph showing the demand for milk decreasing, where your demand curve shifts to the left. Don't forget to label your graphs. Last question now. Show the effect of an increase in the price of Pizza Hut on the demand for Hell Pizza. Firstly, Pizza Hut and Hell Pizza are substitutes. Who would ever buy one pizza from each one at once? So, when the price of Pizza Hut increases, the demand for Hell Pizza increases. If Pizza Hut got more expensive, you'd just buy from Hell. So, we need a graph showing an increase in the price of Pizza Hut and a graph showing an increase in the demand for Hell, with the demand curve shifting to the right. Alright, we've made it to the end now. Good on you for getting through. This was the third video in our Elasticity of Demand series. Next, we'll be looking at income elasticity of demand, where we measure how a change in income affects what we buy. We'll look at luxury items, necessities, inferior, and normal goods. If you'd like to access more practice questions and other resources, head to www.bigbrainenergy.co.nz. If you found this video useful, please hit the thumbs up button and subscribe to our channel. It's a little thing for you, but it means that we can keep making more educational videos for you. If you have any questions about what we've covered today, let us know in the comments below and we'll reply to you. You can also let us know what topics you'd like us to cover next. See you next time for some more Big Brain Energy.